Okay, in this lesson, we're going to learn how to find something called the linear function of best fit. So we're given some data here. We've got an input called x and an output called f of x. Who knows, maybe this is the temperature and this is the width of a metal rod. And we need to determine whether or not this is a linear function. We're going to do that by finding what's called the linear function of best fit and seeing does it fit perfectly or not. If it does fit perfectly, then this represents linear data and it can be described with a linear function. If the linear function that best fits this data doesn't perfectly fit this data, then this data is considered not linear. So we're going to be using the Wolfram language to input this data and find the linear function of best fit. So let's get started. So first of all, we need to enter this data. You're going to open up a new notebook in the Wolfram language, okay? And you need to input the data. So you type data1. You can type any name here. You can name it anything. I'm going to call it data1 because it's problem number 1. Data1 equals. Now we're going to enter our data as a set of coordinate pairs. So the coordinate pairs in this language are also using set brackets. So the first one is 0, 4. So I go here and I type 0, 4. Now comma again. So that's the first element of our set, 0, 4. Next one is 1, 7. So 1, 7. Next one is 2, 10 and 3, 13. 3, 13. So now notice I have a set, a big set brackets, and then inside I have 4 other smaller set brackets that have commas, and each of those is separated by commas. Now, in the Wolfram language, you evaluate this line or store it by doing one of two things. The little gear icon, you can say evaluate cell, or if you have a keyboard handy, hold down the shift key and hit enter. And that sort of finalizes it and stores this set as data1. Okay, so now I need to find the linear function of best fit. So we use a function called findFit. Caps do matter, so capital F, and now this is a function, so we use open brackets, not a set bracket, square brackets. So findFit, and now we put 4 things inside, okay? What data do we want to use? Well, we're going to use data1. Okay, that's the name of our data up here, so that's inputting all of this. And then we do a comma. Now we need to put in what type of a function do we want. And watch, it's going to be a times x plus b. This is, notice, your linear function format. Something times x plus something. Okay, and then we need to tell it, since there are 3 letters here, A, X, and B, Wolfram doesn't necessarily know the difference. We want this to be the main variable and stay a variable. We want to find numbers for A and B that make this function what it is. So we do a set, and then we do A, comma B, another comma, then X. And then we close the square brackets. So let's summarize here. Find fit on data1. We need the function in this format, and we're telling it these 2 letters are really the numbers we need to find. Is it 3x plus 5? Is it negative 6x plus 18? We need to know the numbers for A and B, so that's the next thing. We say A and B are the ones we need to find the numbers for, and then x is our general variable. So there's 4 inputs to the function. Data1, comma, ax plus b, comma, a comma b, comma, x. And now we hit shift enter or evaluate cell. And what it's going to do is it's going to tell us what the a value and the b value should be. So it's telling us that a should be 3 and b should be 4. That will give us the best fit function. So now we want to enter that function in. So normally, if this was, you're writing it on paper, you would write f of x is equal to, a is 3, so 3x plus 4. That's what it's telling us. A is 3, B is 4. So normally we would write this, but not in the Wolfram language. In the Wolfram language, you've got to make differences. Okay, so it's not those type of brackets, it's square brackets. And when you're defining a function, you need to put a little underscore after the x, okay? And instead of an equal sign, you need colon equals. This is the assignment, okay? So f of x is assigned this function. And then we hit Shift, Enter. Doesn't show us anything, but now it's given us this function, and now we can test all of the values. So let's put in f of 0. So f square bracket 0, n square bracket, hit Shift, Enter. It gives us a value of 4. So notice this function predicts this output exactly. So if we go back to here, on our worksheet we're going to write that the predicted output is 4 when x is 0. So our modeled function perfectly predicts for 0 anyway. Let's check the other ones. So f of, let's try 1 and see if it gives us exactly 7. It does. Now let's try f of 2. You've got to check them all. That's 10. And f of 3 gives us exactly 13. So we would come over here and write 4, 7, 10, 13. And this would show us that this is a linear function. And the linear function is f of x is equal to 3x plus 4. That is the perfect function. So on our worksheet, and I don't have something to write with on here, but we're going to write yes here. We're going to write 4, 7, 10, and 13 over here. Those are our predicted values. For g of x, that's what we're calling our model. We're going to write f of x is equal to 3x plus 4. And since it is a linear function, we are going to write 3x plus 4 again on the f of x line. So again, the directions will clarify why there's a g of x and f of x. But that's how you use the Wolfram development platform or the Wolfram language to find that linear function of best fit and determine whether or not the linear function is a perfect fit for the data, and therefore the data is indeed linear.